So welcome back to another No Name Box Mods video here. I guess I could throw up my logo on the screen here or something. So what are we doing today? This is not your typical build video, but this is kind of how I prep for releasing a new kit. Um, one of the parts of that is creating drilling diagrams for the different products that I offer. And if we go in here, find my diagrams, where they go? I do have a bunch of them. So here is an example of the DNA 200 kit that I offer, and zoom out here a little bit. So this program is kind of nifty because you can group things together and basically accumulate a bunch of lines and boxes together, and it prints out to real world scale on a piece of paper. So you can slap it on the side of a box and use it to figure out where you're going to drill. These do usually take me, I don't know, I want to say an hour to do or so. They're not really worth it if you're doing a one-off, but if you want to get really precise where you're drilling your holes and everything, it's not a bad idea. And I figure one of the other benefits of doing this video is you can go in and edit the drilling diagrams that I offer. So if something isn't exactly where you want it, or you want to move a little part around, like I just ungrouped this here, so you could move that a little if you wanted. Or if you don't like where the holes are, or you need something different. Basically, that's why I'm doing this. So close that out. So this is Inkscape. Inkscape is a scalable vector graphic editor. And what that means is instead of drawing pixels onto an image or something like that with something like Photoshop, this is more like Illustrator, but it's free. So I like that. Basically, you work with a bunch of objects. In this case, here is a box, and I'm just going to give it a thicker line here so we can actually see it. So this box is just like an object. We can scale it around, resize it. We can give it precise measurements up here if we want to give it a specific size. So that's kind of helpful. Also, you can draw straight lines very easily. There are some deficiencies in this program, I will admit, but it's free, so you really can't complain too much. There's a Bezier tool if you want to do curves, and you can move these points around and stuff like that. So in all, it's a pretty helpful program. You can find Inkscape here at inkscape.org. Download it for free. I believe it's available, on every major operating system. So I'm using it here on Mac, but you can use whatever version you want. Let's take a look here. So today the kit that I'm developing this for is what I'm going to call the MicroFET, and that will be two 18350 batteries, the really small ones, in a very tiny little box. And this is a tool that I created. I wrote this in JavaScript and scalable vector graphics for the browser. And basically all I did was import a bunch of the dimensions for all the different Hammond boxes that they have, and kind of coded it all together. It's really not fancy, but it works. So to give you an idea, this is a 1590G box. That's the small one, and then we can throw one right next to it. That's the 1590B. And these are pretty accurate. You can use this little calibration tool over here. So you click calibrate, and then in this case you hold up a dollar bill and you resize this box until it matches that, and then you'll have a good on-screen representation of these sizes. And then you click that and it goes away. I think you might need to redo these. Like I said, This is nothing fancy, but it works. So if you're looking for a different box or something and you're not sure um, how big all your parts are going to be and everything like that, you can pull this tool up and it's free to use. It's available on my website and it'll give you all the dimensions. So we got our outside dimensions here, these blue ones, and then between the screw posts, which is something to keep in mind because these things get in the way, this purple line with the purple numbers, and then wall to wall is the red lines here, and of course that's all listed up here. And then if you want even more detailed, you can go to the data sheet, and I just opened that in a new tab here. So you can look at a PDF of all the different dimensions that comes directly from Hammond. So there's that. Today, the box we're actually going to be working with is the 1550Q. So as you can see, this is a very small box. It's incredibly tiny. And I'm just going to open up the data sheet so I have that for reference. Get that open here. So this is kind of what we're going to be modeling in the 2D, and I'll get rid of all that junk. So some basics with Inkscape. I mean, you can watch a ton of videos on this on YouTube, but I'll just go over the basics of what I use to get these drilling diagrams done. I've already showed you the box tool, which is helpful. So you can draw boxes, and then you double click on them, you kind of go into this edit mode, and up here you have your width and height, which is helpful. I like to work in millimeters because that's what most of the diagrams are in. So if we go ahead and switch back over here, yeah, let's just work with these. So let's see. It's always fun figuring out which ones we want here. Okay, this is what we want. The side of the box, the wall of the box is what we're going to model first. And that's going to be this 26 millimeters right here. And then the box is going to be oriented, so I got one dimension longer than the other here. The shorter dimension is going to be the side with the fire button on it, and the longer one is going to have the 510 connector right about here. Maybe I'll edit in a video shot of the box I already made for this that I'm kind of going off of here. So let's see here. So 26 millimeters by, I don't want that one. Let's see. 26 by 55. So that's what we'll make the first one here. Alright, so that gives us a box the size of the wall that we're going to work with. And just clean up the width of the line here just a little bit to make that better. And I'll zoom in here. Hopefully I can turn on the keyboard event thing so it'll show what keys I'm pressing here, but that was just the Alt or Command key with the plus and minus to zoom in. So we got our box. The other major tool that you're going to use, and all of these side menus here I should mention, are available up here in Object. So fill and stroke, that's the one for filling and determining the line size and all that stuff. The other one we're going to want to use a lot is align and distribute. So that's going to be this tab. These are probably the tools that I use the most. And you also have to get used to this, I guess. So when you select two objects to align to each other, let's say I draw another box here. So we got our big box and we got our small box. So big, small. Say we want to center this box on this one. So with the relative to last selected, we first click on the one we want to move, hold shift, and click on the one we want to align it to. And then you can use these buttons to kind of joggle it around like that. You We can move it around, up, down, bottom, left, right, all of these things. And then these ones are kind of interesting but not too useful. They move it to the side, the outside. Now, something to notice here. If we zoom in, you will notice that the box has been created to one thickness of the line. One thickness of the line to the right of it. So it is taking that into account, which is kind of a problem when you start doing these, the measurements that we'll do in a little bit. So keep that in mind. It's much better if we were going to do something like this to over measure another box and then kind of align it to like the top right of it, like this. So that will keep our measurements sound. And the thing to keep in mind is these measurements that we're creating for these boxes are to the outside of the line. So this one we had set at, let me change that to millimeters again, 55 and then 26, I believe. I think that changed because of the line. Yeah, and to note, you probably want this option here turned off. When scaling objects, scale the stroke width by the same proportion. Probably just want to keep our lines the same size. So keep that in mind. Alright, so we got the side of our box, and one of the things that I like to do on all my drilling diagrams is put lines for what essentially become the screw posts. So I'm just throwing in another one here. And the height is going to be 26. Go back to the diagram here. We got a good measurement for that. Alright, so we got the size between the screw posts here, which is helpful. So I'll bring up a calculator. And we have the overall size. So we have 55 minus 39. So that's going to be 16. And divide that by 2, obviously, because there's 2 screw posts. So each one of those screw posts is going to be 8 millimeters wide. And for people who haven't watched my videos before, why does it keep overcorrecting that? For people who haven't watched them before, I like to make these little lines to make it real easy to line up the diagram on the side of the box. If you're not familiar with Hammond boxes, they have curved corners on them. They have a radius, and trying to line up the ends of a piece of paper on a radius just doesn't work that great. So what we do is we create these lines that will then show up on the outside of the box, and then you can compare it to the inside. And what you're essentially doing is just lining it up with that side of the screw post there. And I like to make these dashed, just to make the point that they're not cutting lines. Guess I'm being a little picky here. There, that works. And then we can duplicate this item, which is helpful. So there is a second one on there, and I just used Control D to do that. And I'm going to select the main box and align it to the right, and there we go. We got a nice mirror. Now the other thing to keep in mind when you're doing this is the box has its own height, and then the lid also has its own height. So here we have a total of 30.1 millimeters, and we know the lid itself sticks up another 4.1 millimeters. So that, yeah, puts us in line with that 26 millimeters. But what we want to do is we want to get the button centered on the box with the lid included. And if we look at that, so 30.1 is is going to be like, what, 1505? Divide that by 2? Yeah, 1505. So I'm going to draw another box here. And the dashed is fine. We'll make it width 55 and then 15.05. And I'm going to assume this is the open, this top edge here is the open side of the box. So we'll line that up again. And now this looks offset because it is, but if we throw on the width of the lid, which I believe was 4.1, so we'll pretend that's sandwiched right on top there. So with the lid, we have our full dimensions of the box, and then this will be our center line right here. And I really don't understand why this thing keeps jacking up my dimensions. Oops. Like I said, this is a free program, so can't complain too much. So here is our good center line for where our button's going to be drilled. And I'll delete that. The button I'm using is, let me find that. Where is that document? Here we go. Sorry, I'm off screen here. Alright, so the button we're going to use, I'll pull that up just so we can get the data sheet on it. There we go, the little clicky dome buttons that everyone loves. So here is another wonderful diagram that we can go by. And let's see, where's the good 5,2. I'm going to assume these are in millimeters, since they probably are. Okay, that's the vertical mount one. So yeah, this is going to be our drill width, 5.2 millimeters. So now we get a circle. And we'll take the dimensions on that, 5.2, 5.2. Make the lines solid again. And then we can, alright, here's one of the issues that we have to deal with here. You can't center an object on the side of a box. So here's one little cheat. Make a straight line, relatively. And we can make sure that it's straight by going in here and exaggerating the y coordinates on each of the points. And that assures that the line is straight. And then we can line it up to the top of this edge. There we go. And then we can center the button on that. And now this will be the center when we have our lid attached to the box. And I think that is just about right. Our total width on this button, because we don't want it running into the screw post. That is one of the other benefits here, is we know where these screw posts are now. Let's see here. Oh, here we go. So 7.4 is the overall. And if we wanted to, we could give ourselves a little guide here. And I'll just throw a dashed line on that so we know we're not cutting it. And we can center that on the circle. Sorry, I'm moving a little quick here. One of the other tricks you can do is you can group objects together. Group, ungroup, makes them act as the same kind of object. I use Control G here for that. So now we have our circle and square together on that line, and we can just kind of nudge it over. Maybe, yeah, that's probably good. Now for this kit, I'm going to be using the MOSFET board that I sell on the website here. I do sell these individually. So this is the board that is going to be packed in right about here, and I think it's going to overlap the button just a little bit, but it shouldn't be too much of a problem. So this is pretty much the button side of our box. If this were I guess we can just delete that line now since we have that where we want it. And if this were a bigger box with a voltmeter, we can pretend that it is for a second. You could resize another box here for your voltmeter cutout and, you know, come up with it just the same as any other one for like a screen or something like that. So that is that one. Let's see here. Get rid of that junk. Now let's make the top of the box. So I'm going to select that all and group it together in one object, and then I'm going to duplicate it. Nice and easy. You didn't have to group it together, I guess, but I'm just going to ungroup it again. And I'm also going to get rid of that drill hole. Then we need to look at these dimensions again. Let's see here. So the wide side we have 60 millimeters. So that's what we're going to expand this one to. Actually, I'll do it in here since that seems to be messing up quite a bit. And we just need to realign our screw post here. So we knock that over, and we'll edit this one to be 60 millimeters as well. Now, the prototype that I built for this box, the 510 connector, which I'll represent here with a 22 millimeter circle. That's pretty close for drawing it. So here is roughly the space the 510 connector from Fat Daddy Vapes is going to take up. And with the inclusion of the lid, which will represent as a 4.1 millimeter height box here, that happens to be 60 millimeters. Just kind of throwing this on here for reference. So it'll probably look about like that. Getting the battery sled, which I could find here if I look. So here's another important thing to consider when you're doing this, is what are the major parts you're going to be trying to fit into these. So here is the 18350 battery sled that I'm going to put in this. And let's see here. Let's rotate that so we can see it. This battery sled for this box is kind of big. It's kind of comical how all of this ends up getting jammed in there. But if you look here, this battery sled is 39.78 millimeters wide, and that's going to end up, let's make a box here, just so we can plan this out. .78, and then what's our height on this? Oh, the hell, they don't give it in, alright, I guess we'll have to switch to inches for that. And the height is 0.585. And what's nice is it will switch back and forth here and convert the sizes for you. Alright, so this represents our battery sled from this view. And the other thing we have to take in consideration is there is a bottom thickness of the wall right here. And we can figure that out in here. There is a way to do this. I've done it before. I think I usually just assume that it's about 2 millimeters. Which... Well, inner box height doesn't give us at all. Wall thickness 1.5 millimeters. So that's what we'll assume here. Give us another one. So if, you know, people might be wondering why I don't just use a CAD software. Honestly, because I don't have $9,000 to spend on SolidWorks. I have used it before. It was a wonderful program. But I don't have that kind of budget for this stuff, and I'm doubting most people don't either, although some might be inclined to pirate it. Alright, so that represents the bottom of the box there, and then our battery sled, which is roughly this size, is going to go right about here. And then if I recall correctly, the 510 connector, the screw portion of it, is 10 millimeters. So draw another box to represent that, or circle rather, and we'll align that to the center of this one. And you can see this is where it starts to get tight. I'm going to group that together, but I'm going to make this one solid because we're going to end up drilling this out later. Alright, so we got that. And so what you just saw there is I grouped it together and then I kind of drilled down into the object, and when you do that you can select the elements individually and you can get back out and it's one object again. So that kind of was, I glossed over that, and I'm sorry. And to give us an idea here, the other thing to keep in mind is this 510 connector has a nut on it, and I don't have specific measurements on that right at this second, but we can imagine it goes out to about here-ish, I'm going to say, so maybe half the distance between these lines. And that will be a problem if you try to screw this in right next to the screw post, because it'll run into it. And we also have to account for the wire coming out of the back of the 510 connector. And that, if we put it down here or whatever, in this very short box, it's going to run into the batteries and the connector and everything. So ideally we don't want this hanging over the edge of the lid even, and we don't want it too close to the edge of the box right here or it'll break, and we don't want it running into the batteries. So this is mostly a simple wild fucking guess basically of where this should end up. And I'm gonna guess, I don't know, this feels goodish. Yeah, this is exact science right here. I'm just gonna draw some crosshairs for the drill target here, and make sure this is a straight line again. 774, 774. Hey, I drew a perfect line. Wow. That's magic. And I'm going to make that 22 millimeters wide. There we go. And I will center that on the drill here. that in place. Now I'm going to duplicate that line, so I got another one, and then rotate it 90 degrees, and we have a nice little crosshair. And then we can select all of that together and group it, and we have our nice little drawing target. So that is actually the vast majority of this drilling diagram. We have a tiny little button on the side to fire it, and we have a 510 connector. So there you go. That is how I make drilling diagrams. Obviously you can go back in here and clean some of this up so it's a little more obvious. You can throw some labels on here. What are these? This is a 7/16 hole. And this is a 13/64, if I remember correctly. And you can throw some arrows in here if you really want to be fancy. So we can go over here to stroke and put an arrowhead on it. Alright, that didn't work very well. Close enough. You get the idea. But obviously there are a ton of drilling diagrams on my website, and I do offer all of the scalable vector graphics with them. So if you scroll down, you'll see the drilling diagrams area, and this is PDF, this is the SVG, this is the file you'd want to edit if you want to go into Inkscape and do it yourself, and then there's obviously just the PNG file. As I note in pretty much all the videos, don't print out these diagrams from your browser. Like if we open up this PDF here and go to the print preview, what will happen, at least in some browsers, is it will condense and add margins on, and you don't want that because it'll put like the title of the page and a bunch of annoying stuff like that. So that will squish everything together and throw off the scale of everything. So when you do print these out, just take a ruler and check your measurement, like right here. That's what that scale is for. So there you go. Have a good one.